several years ago, 6, 7, 8 years ago, we developed a version of the PanScan Freedom that allowed you to lower the microscope into a magnet. So we could get to 7 Tesla years ago. However, it required a separate cryocooler, and it completely obstructed the view of the microscope. So the PanScan II, we don't obstruct at all the view of the probe sample. So there's a couple different positions of the microscope. For the maximum field, the head is somewhat blocked by the magnet, but you can raise and lower it into the magnet. So at 7 Tesla, you don't have optical access, but lowering it down a little bit, you're in the 3 to 4 Tesla range. The lumen option, the light collection option is still there. So we can still, inside of a high magnetic field, get the high light collection efficiency. The PanScan Freedom has had by far the highest visibility to the probe sample, where you can find features as small as 2 microns in size. So you can position the sample over the probe or the probe over the sample to find little tiny features, little 2D flakes that are simply not visible with other kinds of systems. Some people say, well, we can get 10 or 20 micron resolution. We can get 2 microns resolution, inside of the magnet with an unobstructed view. So with the lumen system, the first generation, the probe scanned. So the hot spot of the laser, if you really are trying to get as high resolution as you can, it's only 1 or 2 micron size. So once you get past a 1 or 2 micron scan size, you're outside of the hot spot of the laser. So there's lots of measurements you just can't do. If you need a larger range scanning, it's precluded if you have a probe scanner. So we have a version, 2 versions of the PanScan head, one that scans just the probe, as we've been doing, but then there's an auxiliary scan system where we can scan up to 15 microns in X, Y, and even Z down at the base temperature. So when you're using that scanner, the probe's not moving, the laser's focused on it, and then you can scan over very large areas on the sample. So that really, with some people, they had sample scanning systems, or they had a version, somebody else's microscope that's got a big scan range, but it was completely useless at atomic scale. It just didn't have the sub-angstrom resolution that's required for many kinds of experiments. With our system, you can have the best of both worlds. You can have very large scan area, but still have very strong atomic resolution.